Activation functions are crucial components in artificial neural networks, ANNs, as they determine the output of a given neuron. Put simply, activation functions act like a switch, determining whether the neuron should be activated or deactivated based on certain criteria. In other words, they determine whether the neuron should fire or remain silent. As such, activation functions play a pivotal role in controlling the flow of information between neurons and ultimately determining the behavior of ANNs. Most activation functions can be categorized as either linear or non-linear. Linear activation functions have the property that, when presented with two separate inputs, the output is equivalent to a linear addition of the two inputs. In contrast, nonlinear activation functions generate outputs that are proportional to the degree of activation, i.e., as the positive or negative amplitude of the input increases, so too does the output. The most commonly used activation functions include the sigmoid, hyperbolic tangent, rectifier and softmax functions. The sigmoid function, in particular, is perhaps the most widely used and is characterized by its S-shaped curve. It is often the preferred choice due to its continuous derivative at almost all points and its smooth mapping of inputs to outputs in the range of 0 and 1. For example, in a logistic regression/classification model, this range between 0 and 1 is representative of the probability of an event occurring. The hyperbolic tangent, tan-h, function is similar to the sigmoid, except that its output range is between -1 and 1, rather than 0 and 1. For example, the tan-h function has the property of centering its data around 0 and is thus a common choice in ANNs that employ backpropagation techniques. Finally, the rectifier, ReLU, and softmax functions are commonly used as well. The ReLU function outputs 0 if the input is below 0 and otherwise outputs the input unaffected. This functionality makes it a popular choice in deep learning networks. Lastly, the softmax function is often used in models that require multi-class classification. By normalizing the input values to a probability-like distribution, the output is indicative of the likelihood of the entry belonging to each possible class. In conclusion, activation functions play a vital role in determining the behavior and output of an ANN. By allowing neurons to either fire or remain silent depending on conditions, activation functions are the essential determining factor of the flow of information between neurons and ultimately dictate the performance of the ANN as a whole.